The question says that 4-point charges QA, that is of 2 microcoulomb, QB of minus 5 microcoulomb, QC of 2 microcoulomb, QD of minus 5 microcoulomb are located at the corners of a square ABCD of side 10 centimeter. What is the force on charge 1 microcoulomb placed at the center of the square? So there are 4 charged particles, namely QA, QB, QC and QD, and they all are arranged in a form of a square. Now if we assume that the square has 4 vertices of namely ABCD, and the particles are arranged at the corners ABCD, namely QA as 2 microcoulomb, QB as minus 5 microcoulomb, QC as 2 microcoulomb and QD as minus 5 microcoulomb. We have to find out what is the net force on charge 1 microcoulomb placed at the center of the square. Now let us assume that the center of the square is O, where 1 microcoulomb of charge is there. Now we have to find out what is the net force on this 1 microcoulomb charge. So we know that electrostatic force is given by Coulomb's law, and mathematically it is expressed as force equals to K times QA QB divided by R square, where QA and QB are the charge of the particles A and B, and Coulomb's law also states that the force between these two particles would be along the line joining these two particles. And it also says that like charges repel each other, that is, if the charges have same sign they will repel, and if the charges have opposite sign then they will attract each other, and R is the distance of separation between them. So individually we have to calculate the forces acting by all those 4 particles on this charge at the center. So we see that force AO would be equal to, after applying this formula we will get a force of 3.6 Newton. Now since the charge at the center O and QA have both same sign, that is they both are positive, then the force will be repulsive in nature. Similarly with QC and O, it will be 3.6 Newton because magnitude of the charges are same, and again it will be repulsive. So, and since this is a straight line AOC, so they both will cancel out each other. Similarly we can see about this diagonal, that is DOB. Now force OB would be attractive in nature because this is positive in sign and this is negative in sign, and the magnitude would be given by 9 Newton after applying this formula. And similarly FOD would be equal to 9 Newton as well. Now they both will be attractive and they both will attract this 1 microcoulomb charge equally in opposite directions, so again they will cancel out each other. Now we saw that there are opposite forces and they are of equal magnitude and they all are cancelling out each other, so net force on this 1 coulomb charge particle would be 0. Thank you.